Hello everybody, this is Basim who's joined the Graph, and you're watching the fourth and last video of the Getting Started series that is meant to help you get started with graph databases, Apache TinkerPop, and Gremlin. This tutorial series is based on the Getting Started tutorial on the Apache TinkerPop website, the one you see on my screen right now. In the previous videos, we were writing individual commands or traversals in the Gremlin Console. In this video, we will advance to writing scripts or programs that contain Gremlin traversals and other code. Our program will import data from a text file and load it into TinkerGraph. Let me show you the data we will be importing. The data in this text file represents the votes made by Wikipedia users. We have the ID of the user who voted, and then a tab, and then the ID of the other user they voted for. So each of these lines represents a vote made by a Wikipedia user. And we have some lines starting with a hash sign, so these lines are comments and should be ignored by our import program. When we import the data into TinkerGraph, it will look like that. We have only one type of vertices, user vertices having the label user, and each of these user vertices has a property, userId, and users are connected to other users by votes for edges or relationships. We will create two versions of this import program that will import the data from the text file into the graph database. The first version will be written in Groovy and will be executed by the Gremlin Console. The second version will be written in C#. It will be a regular standalone C# program that does not need the Gremlin Console. Let's start writing the Groovy import program. I will create a new file and call it importer.groovy. And I'll open this file in Visual Studio Code. And I will copy and paste some code. This is because I don't want to type too much in this video, but I'll be typing the important parts. We have this function get or create user vertex. Let's skip it for now. We will come back to this function later and we'll implement it later. The execution starts from here. So we want to create an empty graph. We already know how to do that. We do it by calling TinkerGraph.open. And then create an index for the userId property. I want to skip this step for now because it doesn't make sense at this point. Why do we even need to create an index for the userId property? It won't make sense now, so I will skip it and we will come back to it later and we'll create this index later. Next, we want to create the graph traversal source. So we will say g equals graph.traversal. And next, we need to read all the lines from this text file, ctemp_wikivotes.txt. This is the text file we have here containing the Wikipedia votes, that one that we have open. And after we read all the lines from this file, we will iterate over these lines. And for each line, we will check whether it starts with a hash sign, because we said the lines starting with a hash sign are actually comments and should be ignored and should not be processed. So only if it doesn't start with a hash sign, we will process this line. And we will start by splitting this line by the tab character, because we said we have the first user ID and then a tab, and then the second user ID. So we will split the line by the tab character, and the element, this will give us an array of strings, and the element at index 0 will be the first user ID, and the element at index 1 will be the second user ID. And now that we have the two user IDs, we will get the vertices representing these users. We will either get them from the database if they already exist in the database, or we will create them if they do not already exist. And this is what this function does, get or create user vertex. This is the function we have here above that we did not implement yet. So this function will get the vertex from the database if it already exists, and will create the vertex for this user given the user ID if it doesn't already exist, and will return the vertex either way. And we will assign the vertices to user1 vertex and user2 vertex. So now that we have the two vertices representing the two users, we want to add a votes for edge going from user1 to user2. And we already know how to create an edge. We do it by calling g.addE, and we give it the edge label. In this case, the edge label is votes for. And we say from, the edge will be from this vertex, the user1 vertex, to, and the two vertex will be the user2 vertex. And that's the traversal to create this votes for edge between user1 vertex and user2 vertex. But we're missing something here. This is not enough. All what we have here is a description of how to create this edge. We did not actually send this command or traversal to the database, and no edge was created so far. So to actually send this traversal to the database, we need a terminal step. We already saw an example of a terminal step, which is .next. We know that .next actually sends the traversal to the database and gets the result of the traversal. In this case, the result of the traversal will be this newly created edge, the votes for edge. So next is an example of a terminal step. Another example of a terminal step will be toList. And the difference between next and toList, next gets only the first result of this traversal. toList gets all the results of the traversal. In this case, well, the traversal has only one result, which is the new edge, but some other traversals will have multiple results, and toList will get all of them, while next will get only the first result, and then you need to call next again to get the second result, and so on. So those are two examples of terminal step. A third example is hasNext. HasNext will tell you whether this traversal will have any results at all or will not have any results. So hasNext returns true if the traversal has at least one result, and returns false if the traversal has no results at all. But in this case, we will use another terminal step. The terminal step we will use here is iterate. Iterate is a special terminal step in that it sends this command or this traversal to the database and does not return anything, which is all what we need in this case, because all what we need is to create this votes for edge, and we don't care about getting anything from the database. We don't want the votes for edge for anything. We don't want it here in our client application. So we will use iterate. It does exactly what we need. Okay, so after we finish iterating over the lines and getting the vertices or creating them and creating the edges between the vertices, after we finish doing this for each line in this text file, we want to actually show that the data was successfully loaded in the database. So we will get the number of vertices and the number of edges, and we will print them. So getting the number of vertices is easy. We just say g.v.count to get a count of all the vertices. But again, this is a description of how to get the count of the vertices. We didn't actually send anything to the database or get anything from the database. To send this traversal to the database and get the result, we need a terminal step, and the suitable terminal step that we need to use here is next. Next will send this traversal to the database and get us the first result. And in this case, the traversal will give only one result, which is the count of the vertices. And we know that next will get the first and the only result of this traversal. And we need to do the same for the edges. So we will say g.e.count.next. And this will get us the number of the edges. And then we will print the number of the vertices and the number of the edges. Okay, now it's time to implement this function, get or create user vertex. This function takes two arguments, the graph traversal source and the user ID. And this function will get the vertex from the database if the user vertex already exists in the database. And if it doesn't already exist in the database, it will create it. And the function will return the user vertex either way. So to implement this function, I'll start by defining the variable user vertex. And I will return this user vertex at the end of the function. And then we need to write the traversal to get the user vertex by the user ID. So to do that, I'll say g.v. And note that the user ID that I have here, this is not the vertex ID. See, the user ID, this is just a property on the user vertex. It's not the ID of the vertex itself. If I had the vertex ID, I could have said g.v user ID to get the vertex by its ID. But we don't have that in this case. We only have the value of its user ID property. And to filter the vertices by property value, we use the has step. And has, my preferred overload of the has step is the one that takes 3 arguments. The first argument is the label of the vertex. So here the label is user. And the second argument is the property name. Here the property name is user ID. And the third argument is the property value. Here the property value is the user ID that we received as argument to this function. And again, this is just a description of the traversal of how to get the user by their user ID. We did not send anything to the database. We did not get anything from the database yet. To do that, we need to have a terminal step. So the question is, which terminal step should we use here? Should we use .next? Well, it's not safe to call .next when you don't know whether this traversal will return any results at all. Because if this traversal does not return any results and you call .next, you will get an exception. And this is very possible because we know that the first time the function is called with this user ID, the user vertex will not exist in the database and we will need to create it. So this traversal can very well return no results. So we cannot just call .next like that. We need to first call hasNext to see if the traversal will return at least one result. And if hasNext returns true, only then it will be safe to call .next. So here is what I will do. First, I'll save this traversal in a variable. Let's call it user traversal. And again, what's saved in this variable is just a description of the traversal, not the traversal results. And then I'll do a test. I'll say if user traversal.hasNext, only if hasNext returns true, it will be safe to call user traversal.next. So I'll say user vertex equals user traversal.next. Else, if this traversal doesn't return any results, this means that the vertex does not exist in the database and we need to create it. So to create a vertex, we say g.addv, and addv takes the vertex label. In this case, the vertex label is user. And then we need to set its user ID property, right? So to set a property, we say .property, and the property name is user ID, and the property value is the user ID that we received as argument. And again, this is just a description of the traversal. Nothing was sent, nothing was retrieved from the database. We always need a terminal step. So here the terminal step is .next. This will send the command to the database and execute it, and will return the traversal result, which is in this case user, the newly created user vertex. I'll assign it to this user vertex variable. So now we have the user vertex set in the 2 branches, and we will always return the user vertex, either the existing user vertex that we fetched from the database or the newly created vertex that we created here. And I should note that this is not the most efficient implementation of this function. In the implementation right here, we did 2 round trips to the database. The first round trip was to check whether this traversal will return any results, and the second round trip either fetches the vertex from the database or creates the vertex and fetches it if it doesn't already exist. So in total, we made 2 round trips to the database. There is a more efficient way of writing this traversal, of writing only one Gremlin traversal and doing only 1 round trip to the database to implement the same function. And if you're interested in seeing this more advanced and more efficient implementation, you can go to the official Apache TinkerPop website, their Getting Started tutorial, and near the end of the tutorial, you will see an alternative implementation for the same function. Their implementation is mostly based on the coalesce function, and this function either returns the existing vertex or creates a new vertex and returns it. So it's more clever, more efficient, but I believe the implementation that I used here is simpler and more suitable for a getting started tutorial. Anyway, let's move on. And the last thing we need to do to complete the script is creating an index for the user ID property. Now it's more obvious why we need an index on the user ID property, because this traversal we have here, it searches the vertices by the value of the user ID property. And this will be executed, this traversal will be executed so many times, because remember this function right here, get or create user vertex, it's called twice inside this loop that will be executed for each of these lines in this huge text file. So this traversal will be executed so many times, and we need it to execute as fast as possible. And when you want to make it easier and faster to search by certain property, then you want to create an index on this property. Searching indexed properties is like searching for names in the phone book, for example. If you're searching for the name Basim in a phone book, you know that you have to go to the letter B and then look for BA, then BAS. You know how to get to the name quickly. But searching non-indexed properties, this will be more like having a phone book that has the people's name in it in no particular order. And if you want to search for somebody, you just have to scan the entire phone book until you find the name. Of course, this will be very efficient. So this is called linear search or full table scan, when you're just searching blindly without having an index on the property. So whenever you expect to search a lot by a certain property, it's a good idea to create an index on this property. And that's why we need an index on this user ID. So how do we create the index? Well, the way you create an index, it depends on your graph database. Right here, we're using TinkerGraph. So the way you create an index in a TinkerGraph is that by using graph. And remember, we never use the graph object for anything other than creating the traversal source. But here we'll use it for something else. We'll use the graph object to create an index. So we will say graph.createIndex. And the first argument will be the property name, which is user ID in this case. The second argument will be, we will have to specify whether this index will be created on a vertex or on an edge. Here we're creating it on the user vertex, so we're creating it on a vertex. So we will say Vertex.class. If we were creating it on an edge, we would have said edge.class. And that's it. We just completed implementing this Groovy script, and now it's time to execute it from the Gremlin console. So I will start the Gremlin console. And I will zoom in to make everything bigger. And what I used to do before, I used to copy and paste into the Gremlin console. Now I'll do it a little bit differently. Instead of copying and pasting the code, I will tell the Gremlin console to load the command from this text file. So first I'll copy the path to the file. And then in the Gremlin console, I'll type :L for load. And then I will paste the file path without the quotation marks. And I'm executing it right now. And we're expecting to see this message right here. Database contains number of vertices and number of edges. And we did get this message. So it contains that number of vertices and that number of edges. So the data was loaded successfully. So far, all the code that we wrote in this tutorial and in the previous tutorials was Groovy code. And we have been using the Gremlin Console to execute our code. But I assume that most people watching this video are application developers. Like me, I'm a web developer, and I use C# and ASP.NET to build my web applications. So you want your application to talk to the graph database. Your application may be written in Groovy or Java or any other language. And you will want to write these Gremlin traversals in your application. To enable your application to talk to the graph database, you need to have a Gremlin server running. This Gremlin server will listen to requests coming on a certain port. These requests are mostly Gremlin traversals sent in bytecode format, and the server will work with the graph database to execute these traversals. The graph database can be TinkerGraph, GenusGraph, or any other graph database. What I want to do now is create a C# application that does the same thing that the Groovy script did. So no more Gremlin Console, and we will need the Gremlin Server, which can be downloaded from the Apache TinkerPop website. So I'll go to tinkerpop.apache.org, and right next to this button that's used to download the Gremlin Console, you have another button to download the Gremlin Server. So you will click that, and then you will click this link to download the Gremlin Server. I already did that, and I have it on my computer. So I will start it now. I'll go to the bin folder and I will run gremlinserver.bat because I'm on Windows. And you will see now the server is running on this port, 8182. I will create a folder for the C# program. And I will call it importer CS. And I will open this folder in Visual Studio Code. And now I will open the terminal and I will create a new .NET console application. You do that by typing .NET new console. And this should create the CS project file and program.cs. Now I will copy and paste some C# code. I will first add these assets. And you see we have all these red squigglies. It says that the Gremlin namespace is not recognized, and all these types like Gremlin Server and Gremlin Client are not recognized. And the reason for that is that we did not add a reference to the Gremlin.NET library yet. We need to include the Gremlin.NET NuGet package. And I do this by typing in the terminal. We'll say .NET add package, and the name of the package is gremlin.net. And after the gremlin.net NuGet package is added, we will see that this namespace will be recognized and all the gremlin.net types will be recognized. Let's now look at the C# code that connects to the Gremlin server and creates the graph traversal source. It starts by creating an instance of the Gremlin server, and the Gremlin server constructor takes two arguments. It takes the host name, in this case it is localhost, because both the server and the client application are running on the same machine. And the second argument is the port number. This is the same port number that we got here from the Gremlin server, 8182. This is the port number that the Gremlin server is listening to. And after you create the Gremlin server, next you create the Gremlin client, and you give it an instance of the Gremlin server. You pass it to its constructor. And the Gremlin client is a disposable class. So you need to declare it using the using keyword, so it is disposed of at the end of the scope. Next, after creating the Gremlin client, you need to create the driver remote connection, and its constructor takes an instance of the Gremlin client. And finally, you create the graph traversal source, the G object, and you configure it to use the driver remote connection. So it was quite a bit of code, but nothing too crazy. I mean, we used to create the graph traversal source only in 2 lines in the Gremlin console. Here, it takes 4 lines of code, but you end up with the same G object, the same graph traversal source. And you use it almost the same way you use it in the Gremlin console. Next, ideally, we would like to create an index on the userId property, just like we did in the Groovy script. But I could not find a way to do this from a C# application. And the reason is the creation of indices, this is not really part of Gremlin. This is specific to the graph database that you're using. Here we are using TinkerGraph. And TinkerGraph does have an API for Groovy programs to create an index, but I don't think it does have an API for .NET applications to create indices. At least I couldn't find one. So I don't think there is a way to create an index in TinkerGraph from your C# application. I might be wrong on that. Please correct me in the comments if I'm wrong, but I don't think there is a way to do that from your C# application. It's only possible if you're writing a Groovy script in the Gremlin console. So anyway, we will just skip this step and we won't create an index on the userId property. And next we will read all lines from this text file, from the wikivotes.txt file, and iterate over these lines again. The code is very similar to what we did in the Groovy script. We will skip the lines starting with the hash sign. And then each line we will split it by the tab character. The element at index 0 will be the user1 ID, element at index 1 will be the user2 ID, and then we will get or create these user vertices. And next we need to add the votes for edge going from user1 to user2. Now I want to show that your Gremlin C# code will be very similar to your Gremlin Groovy code. They are almost the same. So what I'll do, I'll be copying and pasting from the Groovy script. Because they are so similar, I can just copy and make small modifications to the code to make it valid C# code. So this is the line to create the votes for edge. I'll copy it from the Groovy code and I will paste it in the C# program. There is only small syntactic differences that I need to do here. I mean, Gremlin is Gremlin, except for small syntactic differences depending on the programming language you're using. Here in C#, function names always start with capitals, so it will look awkward if Gremlin.NET had function names starting with a lowercase like add e. So the only change I'll make here, I'll capitalize the first letter of the function name add e. It's the same function name, just different capitalization. And then strings in C# are surrounded by double quotes instead of single quotes. And again, the from function starts with a capital, and the to function starts with a capital, and the iterate function starts with a capital. And these are the only differences between the C# Gremlin code and the C# Groovy code. So I'm sorry, and the C# Gremlin code and the Groovy Gremlin code. So you can see that Gremlin is Gremlin, no matter which programming language you're using it from. Only very minor syntactic differences. Okay, and now let's move on to getting the number of vertices and the number of edges and printing them. You will see these Gremlin traversals too will be very similar, so I'll copy and paste them. I will make the first letter uppercase. The first letter of the next step will be uppercase. And then I'll copy the traversal for counting the edges. And again, I will capitalize the first letters of the function names. So once you learn how to write Gremlin, you can very easily use this knowledge to use Gremlin from C# program or from Groovy, Java, Python programs, Go programs, any programming language that has a library for Gremlin. Okay, and then we will write to the console the number of vertices and the number of edges. And now let's implement this function to get or create the user vertex. Again, the implementation will be very similar to the Groovy implementation, so I'll copy and paste. Well, the difference between one of the most important differences between C# and Groovy is that C# is a strongly typed language. So I cannot just define a variable like that. I have to specify the data type of the variable. The data type of the user vertex will be vertex. And the data type of the user traversal, let's first capitalize this and use double quotes. And what will this has step return? It returns the graph traversal of vertex vertex. So this will be the type of the user traversal. Graph traversal of the vertex vertex. So we need to specify the data types of each variable. The has next step needs to be capitalized, and the next step needs to be capitalized. And add v capitalized for first letter, property capitalized for first letter, and all strings surrounded by double quotes. And that should be it. We just fixed all the compiler errors, and I'll hit F5 to run this program. At the end, we should get this message that will be printed to the console with the number of vertices and the number of edges. Okay, so this took quite a bit, over 10 minutes actually, but the script did complete successfully. And the data was loaded, and we got this message with the number of vertices and the number of edges loaded. So it was successful, but the reason it took so long is, one, we couldn't create this much needed index on the user ID property. But don't worry, this will not be a problem in your production applications, because right here we are using the TinkerGraph database, which is an in-memory database that's mostly used for testing and for playing with Gremlin. But in your production application, you will probably be using something like JanusGraph, which is a real production database that actually saves the data to a persistent storage. And it does have a C# API for creating indices. Most graph databases do. So this lack of index or the lack of ability to create an index will not be a problem in your production application. So this was the first reason it was so slow. The second reason it was much slower than our Groovy script executing in the Gremlin console is because here we're using network communication. Although both the client and the server are on the same machine, but still we were using port communication, which is relatively slow. Okay, now that we finished writing the C# application and the Groovy script, I will create a repository and I will upload all these files to GitHub, and I will put a link in the video description. We finally reached the end of this video and the end of this tutorial series. I hope you guys enjoyed it and learned a few things from it. I know I learned a lot while making these videos. In my next tutorials, I want to explore graph databases that actually save your data so they can be used in production applications. Unlike TinkerGraph, the in-memory database that we used in this tutorial series, TinkerGraph is good for learning and testing, but for production applications, you will need a graph database that actually saves your data to a persistent storage. I will probably start by looking into JanusGraph and doing one or more videos about it. Okay, thank you so much for watching and goodbye.